let's talk how to find end behavior graphically and algebraically. So we're going to take first the graphical approach. Now here on the right, I have given you the 4 different sentences, so to speak, of end behavior that you can have. So we need to make sure we understand what these sentences are explaining in order to be able to choose the options of our final choice. So as you know, on a coordinate plane, we have an x and a y axis, okay? And what I want you to notice is that our x-axis only involves looking left or right. So left or right. And as we move really, really right, our numbers are going to get really big, positively. And as we move very left, our numbers are going to get increasingly large, negatively. Likewise, if we look at the y-axis, or in this case, our f of x function, our y, we're going to label it as f of x, or g of x, h of x, depending on what your function is called. But regardless, the y-axis has the job of analyzing the up-down movement. And just like the x-axis, the further up you go, let me put up, we go to positive infinity, and the further down we go, we get really small numbers, negative infinity, okay? So what I need you to understand is that when you guys have any sort of graph being graphed, the arrows at the ends are behaving in 2 directions. They have a horizontal and a vertical component. In other words, they have a horizontal component, the arrow is either going left or right, and they have a vertical component, they are either going up or down. So let's analyze what's going on in our sentences, okay? So upstairs, the first thing we start here is as x approaches positive infinity, f of x goes positive. So that means as x approaches positive infinity, so here's my x approaching positive infinity, it means as I go right, okay? So I'm going to write this in red. So here, as I move to the right, okay, f of x, basically my function, whatever the function is, now they say the function is approaching positive infinity. Well, the function approaching positive infinity means that the graph is going upwards. So my function approaches goes up. Let's just use the word goes up. Goes up, okay? So that's what that phrase in math means. As I look to the right side, the function is going up. So let's try the next one. This one would be as I move along the x-axis, in other words, as I move along the x-axis to the right. Okay, my graph is going to go either up or down. Since this is negative, my graph goes down. Okay, forgot the word goes. Okay, so you can do that for every single one of those, but instead we have an agreed notation, and that's what's written in purple. All right, so here as x approaches negative infinity, as I go left, my graph is going up. As x approaches negative infinity, this means again, as x approaches negative infinity, on the left-hand side, my graph is going down. So what you're going to do here in this particular problem that you're seeing here on the right, let's do this. I'm going to say it in regular words, okay? So I'm going to say describing the one on the left. So I'm describing this one right here, all right? The one I'm kind of highlighting here, that one. Okay, so I'm looking at the left end. So left end. I'm looking at the left end. And so in regular words, right, I'm saying as I look on the right-hand side, as I look on the left arrow, okay, as I look upon the left arrow, I guess, for proper English, upon the left arrow, I notice it points down. All right, now that's a lot to write. So what are we going to do? In math notation, I'm going to say, as I look upon the left arrow, well, left arrow is this one, right? I'm looking on the left. So left means I'm going to write as I go on the x-axis towards the left-hand side, what do I notice happen? Well, I notice that the graph, and this graph is called f of x, my graph is going down. Notice it's going down. So down means put the little arrow, meaning approaches. It approaches down, negative infinity. And then I'm going to say again, let's say it all in layman's term, as I look at the right arrow, my graph also is pointing down, points down. So instead of writing all this in black, how do I write it in red using the right end behavior notation? Well, I'm going to say, I'm looking at the right, so I need to say x-axis is right and left movement. So as x goes to positive infinity, so that's what that is, right, comma, I have to name my graph. My graph is doing what? My graph is also still going down, so down is negative infinity. So as x approaches positive infinity, let's see which one it is. As x approaches positive infinity, it's going down, and negative. So what do we have? We have two negatives. So this, and it should be this one, if I'm looking correctly. X approaches negative infinity, it goes down, and as x approaches positive infinity, it goes down. Yes. So let's fix that. All right. So hopefully that helps clear up how to do that. All right. Okay, let's do the next type of problem, which it is end behavior graphically. So graphical end behavior does the following. Okay. So here are my options. If my graph is an even degree means the exponent is even, all right? Your ends of the graph are always going to behave the same. They either are both going to go up or they're going to both point in the negative direction. Odd degree, the arrows, odd, opposite. Remember, just like our tables, right? Even gives us same y values, opposite y values. Your options are going to be that the left and right ends are going to point in opposite directions. So these are the only four choices that you have that can happen with end behavior. These are the four combinations. So the first thing you always need to do when looking at a algebraic equation, you're going to look at the degree. Looking algebraically, you are going to find the degree of the polynomial. All right? And if you have forgotten what degree means, it is the highest power of your polynomial, or you want to say exponent. So you have to examine every term and determine which one is the leading term, okay? So what is the degree of this polynomial? Well, if I look at every single one of those exponents, my degree turns out to be a number 3. 3 is an odd number. Because it's an odd number, I automatically get to eliminate the other choices, and my only answer choices are the ones I'm highlighting right now. because it's an odd degree. So far, are we okay? All right. Now, once you know what the degree is, automatically you already then know what your lead term is. My leading term in this particular problem is negative 8x cubed. We already used the exponent to determine even or odd. So now you are going to use the leading coefficient to help you determine something else. Okay? So my leading coefficient helps me with the direction that my arrows point in. If my leading coefficient is positive, that means with respect to odd functions, right? With respect to odd functions, let me give you the two conditions here. Positive means that this is going to be the option. Why? You will always look at the right-hand arrow. Notice my right-hand arrow is pointing upwards. So I'm going to put it in red to make it a point. You're looking only at the red arrow. So if it's red is pointing up, that means my left-hand arrow has to go down because it's opposite. If my LC, leading coefficient, was less than 0, in other words, a negative number, then that means, I wish it would quit writing over what I wrote. That just means that when you're looking at your right-hand arrow, it has to be going down because less than 0 are negative numbers. So that means our option is going to be this one. Okay? So, based on the fact that our leading term is negative 8, and it's negative, I know that this is going to be what's happening with my graph. My left-hand arrow is going upwards, and my right-hand arrow is going downwards. So, in a sentence, left side goes up. And then describing the red arrow, right side goes down. Let's convert that to math writing. So, as far as the black, left side goes up. I'm going to say left is x movement. As x goes to negative infinity, I have to point left. So that described this word, by the way, comma, my graph is still f of x in this problem. My graph goes up, positive infinity. Then the red, let's do the red. They're talking about the right side. So right side says as x goes right. Right is positive numbers, comma, my graph will go where? It's going down, so negative infinity. So there are my answer choices. So with that, x going negative infinity, it has to go positive, and that will be this choice right here. And you're done. Okay? So always remember, with these type of problems, you need to find the degree, and you need to find the leading coefficient. Okay? So again, even, both up or both down. Odd, one's up, one's down, or one down and one up. If the leading coefficient, let's use black. If the leading coefficient is positive, greater than 0, you will either have both ups or the right one up. And let's do another color. Let's use green. If your leading coefficient is less than 0, that means negative, that means pointing down. They're either both pointing down or the right hand is pointing down. Okay? So, even are these top ones, and odd are these bottom ones. So that's how you do it. All right, let's do one more problem. Moving up, let's see, next problem. Let's find the leading the leading term, and the leading term provides us with the degree, and it provides us with the LC. The degree is going to be the highest exponent, which is a 5. So my leading term is 2x5, where the degree is 5, and the leading coefficient is a 2, and 2 is definitely bigger than 0. So because it is odd, I know my options are up, let me see, up or down, and then down or up, because that's odd, right? Opposite pointing. But because my LC is bigger than 0, I want the right arrow to be pointing upwards. So this is my answer. So now I'm going to describe this. This left arrow, and this is going to be the right arrow. Okay, left points left negatively, points right positively. And then what is my function doing? Well, my function is going to approach. The left one is going down, and the right one's going up. That's all you do. So negative infinity, positive infinity, that was this one right here. And you're done. Thanks for watching.